We could charge a capacitor and then short it across the coil. Given the behaviour described above, something interesting has to occur, and it does. And here is the hand-waving argument as to what happens. The charge held on the capacitor demands to rush across the coil, which initially resists, but allows the current to grow. As it does, the magnetic field builds up, but the juice runs out. As the magnetic field collapses, it returns to force the juice back onto the capacitor plates. As this develops, the voltage builds and causing the whole cycle to start again. Back and forth it goes, oscillating like an electronic gong. The rate or frequency at which this occurs is given by this equation. If we make the capacitor or inductor variable, then this frequency varies too. This is a typical variable capacitor. As the plates rotate, the area between the two vanes changes, changing the capacitor and hence the frequency. It's called a tuned circuit. If we run ahead of ourselves a little bit and trap some radio signals, we have made the front end of a radio system here. Here is another thing we can do with our pair of coils. Take one and connect it to an AC signal source. This forces current around the coil, causing the magnetic field to rise and fall. Bring a second coil and resistor close, so that it shares the magnetic field and an AC signal appears across the resistor. Then, when very close, the output voltage is the same as the input voltage. If the primary has, just to pluck any number from the air, 240 turns of wire, and the secondary has only 24, then this ratio is 10 to 1. Plug this into the mains, which is 240 volts AC, or thereabouts, so the output across the resistor would be 24 volts, and we have the front end of a power supply. This is how contactless chargers work. So we've seen two useful everyday devices constructed from this simple circuit.